Welcome to Learniverse. Today we are diving into the world of variables in C programming. Variables are the backbone of any programming language, and understanding them is crucial for building efficient and dynamic applications. Let's get started. What is a variable? A variable in C is like a named storage container in your computer's memory. It holds data that can change during the execution of a program. Think of it as a labeled jar in your pantry. You can fill it, empty it, or refill it, but it is designed for a specific type of content like sugar or spices. Here are three key points. A variable must be declared before use. It stores a specific type of value, like an integer or character. Until initialized, it holds random or garbage values. Let's look at a quick code example to understand this better. Here you can see three different variables that are declared and initialized. First one is of type integer, second one is float, and third one is of type character. And there are additional examples for better clarity. Here in the first line, count is a variable name that is of type int. Here only variable is declared but not initialized, hence it contains garbage value. Second one, variable name is age and it is of type int, and here variable is declared as well as it is initialized to value 25. Why do we use variables? So here main thing is, why do we need variables? They make programs dynamic and flexible. Variables let us store, manipulate, and retrieve data efficiently. Here are some real world examples. In banking applications, they store and update user balances, and for weather tracking they log daily temperatures, and in games they keep track of scores and player health, and also in e-commerce cart management they store the number of items and their total price. Now let us understand types of variables in C. C provides several variable types to handle different kinds of data. First one is of type integer, it stores whole number, and second one is float, it stores decimal numbers. Third one is character, it stores single characters. Fourth one is double, it stores high precision decimals. For example, in inventory management, you would use integers for product counts, floats for prices, and characters for product grades. Let us see an example of how to declare and use these types. Here you can see we have declared and initialized 4 different variables of 4 different types. Now let us see how we can declare variables. In C, variables must be declared before use. The syntax is very straightforward. Here data type we need to specify and then the variable name. You can also declare multiple variables of the same type in one statement. Here you can see the example. So this is a clean and efficient way to manage your variables. Now let us understand all types of variable declarations. So first one is variables can be uninitialized, which means they can contain garbage values until explicitly assigned. Here you can see integer x is declared but it is not initialized, hence it contains garbage value. So here think of one real use case. Here when you leave a room messy, you don't know what is inside, right? Similar to a variable with garbage value. Next one is explicit initialization. here you assign an initial value during declaration to avoid garbage data. For example, here you can see three different variables are already assigned values, which means they are already initialized during declaration itself. So you can consider one real life use case. For example, in accounting software, initialize totals or counters to 0 before processing transactions. Next one is multiple declarations. Here we are declaring several variables of the same type in one line. Here you can see, here we are declaring 3 integer variables in one line, and similarly 2 in floating point variables in one line. It's like we can correlate with one real life example. In gaming, we can track multiple player stats like health, score and stamina. Here you can see the declaration of that. And next one is extern variables. Extern variables are declared in one file and it is used in another file. They are great for sharing global data like configuration settings across files. This is one example. And coming to the real life use case, as I mentioned, shared configurations in multi-file application like database credentials in one file accessed by multiple modules. Next one is static variables. Static variables retain their value between function calls and are limited in scope. This is one of the example. And coming to life use case, count the number of times a function is accessed, like tracking login attempts in an application. Next one is volatile variable. It tells the compiler not to optimize them because their value can change unexpectedly, such as through hardware interactions. So here just one example how we are declaring volatile variable. And coming to the real world use case, in embedded systems, variables linked to sensors or interrupt routines must be declared as volatile. So lastly, register variables. They are stored in CPU registers for faster access. They are ideal for frequently used variables like loop counters. This is an example how we can declare register variable. And coming to the real life use case, mainly we speed up loop counters in performance critical applications. And we do have local variables. Local variables are declared inside a function or a block and accessed only there within the block or within the function. This is an example how local variable is declared and how it is accessed within the function. And also what happens if we use outside the function. You can see the commented line as well. And coming to the global variable, global variables are declared outside all functions and accessible throughout the program. So here you can see the global variable is declared outside all the functions and it can be accessed within the program. So we have to choose wisely based on our application needs which variable is needed, whether local variable is needed or global variable is needed. So next let's understand initializing variables part. So initialization is assigning a value to a variable when declaring it. Always initialize to avoid garbage values. For example, in payroll systems, start employee salaries at 0 and update them dynamically. That is one of the use case. Here you can see the syntax how it is and the examples where it is declared and initialized at the same time. And you can also see the advanced initialization where we are initializing multiple variables. And here initialization during declaration. and here initialization with expressions, and also here initialization after declaration. These are some of the different types of different ways of initializing variables. Yeah, as I already mentioned, this is one of the real life use case where in payroll systems we are initializing employee salaries or any bonuses dynamically based on certain conditions. Now let us understand the scope of variables. Variables have different scopes: local, global, static, extern. Coming to local, it is limited to the function or a block. Global variable, which can be accessible everywhere within the program. And static, it retains value between multiple calls. And extern, it provides shared access across files. So this is a code example where all four types of variables are involved in this particular code. You can have a quick look in the code part so that you will get a better clarity. And also I would like to highlight a real life use case as well. For example, use local variables to calculate discounts on single cart item, while global variables track total users logged into an app. So these are some of the real life examples that I wanted to highlight. And also let's understand rules for naming variables. What are the rules that are there as part of C standard? So when naming the variables, always start with a letter or an underscore. Avoid keywords like int or float. Be case sensitive, and also avoid spaces or special characters. So this is an example. So this is a valid naming convention, and this is an invalid naming convention. And coming to the real life use case, and naming variables is like naming files on your computer. You need to have a clear and meaningful names so that follow system rules. Similarly, here it is a C standard rules. So now I would also like to highlight best practices for variables. So here are some tips. Use meaningful names for better readability. For example, total marks is better instead of just X. And always initialize variables before using it. And then limit the use of global variables. So this is one example where we are having a meaningful name, clear and descriptive variable. Distance is a clear and descriptive variable. So like this we have to name while naming the variable. And then these are some of the real life use cases. For example, in game development project, we use variables like player health or enemy count for proper clarity. And also in software project, descriptive variables like total cost or remaining time will improve collaboration, and it will also help us during the debugging session. And there is advanced tip as well. For example, combine constant with variables to create read-only values. So suppose if we don't want to modify that particular variable, then we can add a const keyword. And then use volatile for hardware interacting variables, and also optimize performance with using register variables. These are some of the advanced tips. Yeah, so that's all for today's session on variables in C programming. Thank you for watching. If you to like, share and subscribe to Learniverse for more programming insights. See you in the next video.